Hello everyone, I am Sapna, Assistant Professor from the Department of Information Science and Engineering, NMAMIT Institute of Technology, Nitte, and I welcome you all to the practical session on agglomerative clustering. In this session, we will learn how to apply agglomerative clustering on the iris dataset, which consists of three classes of data: iris setosa, iris virginica and iris versicolor. The dataset was downloaded from the UCI Machine Learning repository and it is also available in Kaggle. It consists of 150 rows and 6 columns. The first column is indicating the row numbers and it is not of significance for clustering. The next 4 columns indicate the actual features: sepal length, sepal width, petal length and the petal width, and the last column is indicating the labels associated with the data. Since this is a label data set, the next question would be whether we can apply clustering on this data set. The answer is yes, we can apply clustering on this data set provided that the labels will be eliminated. Once the labels are eliminated, we are left with the feature set which can be used to perform clustering. So let us move ahead and apply clustering on these features. I will use Jupyter Notebook for this purpose. The first thing that I will do is I will upload the iris.csv file into the workspace. Now I will be creating a Jupyter Notebook document in order to write the Python code, and I will give it a name. Now the first thing that I will have to do is I will have to read the contents from the iris.csv file and store it in some variable. For that, I will import the pandas library and I will extract the data from the iris.csv file and store it in a variable called iris. So the read CSV function can help me in reading the contents of the CSV file. So once I have extracted the data, I can try and print the top 5 rows in the data set. So the 5 top rows are printed and it shows that the data has been extracted correctly. I am interested in only the 4 features of the data: sepal length, sepal width, petal length and the petal width. But now if I consider all 4 features for clustering, then I will have to visualize the data in 4 dimensions. In order to eliminate visualizing the data in 4 dimensions, I will just consider 2 different features and I will visualize them in 2 dimensions because the visualization becomes easier in 2 dimensions. So how am I going to select the 2 features from the 4 features? I will be selecting it based on the correlation coefficient between the pair of features. I will identify the correlation coefficient between every pair of features and I will be choosing that pair of features which is having the highest positive correlation between them, because a positive correlation between features is a good indicator for clustering. So first I will try to extract all the 4 features from the data and then I will try to plot the correlation matrix. I can do it using the ilog, where I will provide the rows and columns to be extracted. I want to extract all the rows, so I have specified it as colon, and the columns that I want to extract is ranging from column index 1 to column index 4, because ID is the column index 0. Sepal length starts with column index 1, so I will specify it as 1. This is column index 2, column index 3 and column index 4. So last column index to be extracted is 4, so I have to specify it 1 higher than that. Next, I will try to plot the correlation matrix. So this will give me the correlation matrix. If I see the diagonal elements, all the values are 1 because it is indicating the correlation of a feature with itself. If I consider this value of 1, it is correlation of sepal width with itself. So I will eliminate all the diagonal values and I will try to find the largest positive correlation value. The largest one is 0.962757, which is the correlation coefficient between petal width and petal length. So, I will be considering only the petal length and petal width in order to perform the clustering. So, I will extract those features and store it in a variable called as features. So, I am extracting column number 3 and column number 4. So, I will write it as 3:5 and I am extracting it in the form of an ND array. So, I will convert it into an ND array. So, if I try to print the top 5 features, here I will be getting the top 5 rows and it is matching with this data. So, the features are successfully extracted. Now, I will try to visualize the features in 2 dimensions. So, I will have to do that using the matplotlib library. I will extract it as PLT and I will be plotting it as a scatter plot. On the x-axis, I will be plotting the petal length and on the y-axis, I will be plotting the petal width. So, if I do this, I will have to give a title to it. Title, let me consider I am giving it as petal length versus the petal width and I will give it a X label as petal length and I will also give it a Y label petal width and I will display it. So, if I do this, I can see the data points plotted. Now, the next thing that I will have to do is I will have to draw a dendrogram for this data. In order to do so, I will have to import a module that is called as scipy.cluster.hierarchy. So, first I will import it and I will give it a short name as SEH. This library will be providing us with a function called as dendrogram that will help us in creating a dendrogram. I will create the dendrogram and store it in a variable dend. Now, what is the argument that I pass to this? The argument that I pass will be the linkage matrix. Now, how am I going to obtain the linkage matrix? The SEH library, that is the scipy.cluster.hierarchy, has a function called as linkage that will help me in getting the linkage matrix. So, I will use that function and to this function I will be passing the features for which the linkages have to be calculated and I will mention the linkage criteria using the parameter method. So, if I want to use any of the linkage criteria, it can be specified here. By default, it will be having the value of single criteria, but if I want to change it to anything other than that, I can specify it explicitly. And then I can also specify the metric parameter which indicates the distance metric that I am supposed to use. By default, it takes the value of Euclidean distance, but if you want to change it to anything other than that, say cosine distance or any other distance measure, you can explicitly specify it. But I would like to use the Euclidean distance. Since the default value is Euclidean, I will remove that parameter. Now, if I plot this, I will be able to see the dendrogram. Once we visualize the dendrogram, we can see that the optimal value of k for this dendrogram will be 2 because the longest possible vertical distance will be starting from this point to this point. Even though the optimal value for k from this dendrogram is equal to 2, I know from the data set that there are 3 classes possible for the given set of data. So, I will initialize k as 3 and then I will have to perform agglomerative clustering. In order to do so, I will have to import the agglomerative clustering class from the module sklearn.cluster. So, I will import it from sklearn.cluster. I will import agglomerative clustering. Now, I will generate a model out of it. agglomerative clustering of certain set of parameters. Very important parameter that I have to specify is the number of clusters that I am going to obtain. So, it will be n underscore clusters parameter and k value is 3 because I have already initialized it. The next thing is the affinity parameter. So, this parameter will be specifying the distance metric that I am using. By default, it will be Euclidean distance. If you want to use anything other than that, you can explicitly specify here. So, I will be using Euclidean distance itself. So, I can either specify it this way or I can remove this entirely because by default it will be taken as Euclidean. And finally, the linkage criteria to be used can be specified via this parameter. By default, it will be taking the value of Ward linkage, but if you want anything other than that, you can specify it here, but I will be using Ward itself, I can eliminate it. Now, using this model, I am supposed to fit the features to the model and then I will have to extract the labels associated with the features based on the model generated. In order to do so, I will be using the fit underscore predict function. Model dot fit underscore predict on the set of features. So, if I execute this, it will be returning the labels associated with the features in a attribute that is labels underscore. So, I will have to extract the labels using this model labels underscore. So, if I now try to print the labels, I will be able to see the different labels. So, here I see the label values are ranging from 0 to 2. 0 indicates the label for cluster 1, 1 is the label for cluster 2 and 2 is the label for cluster 3. Now, finally, I will have to visualize this on a scatter plot. In order to do so, I can use this. On the x dimension, I will be plotting the petal length which is present in the first column with index 0 in features, and on the y axis I will be plotting the petal width which is present at column 2 with index 1 in the features, and I will be choosing the colors based on the labels. So, here C is equal to labels indicates that the colors will be chosen differently for different values of labels. So, if I have 3 clusters here, 3 different colors will be chosen randomly and it will be assigned to the data points belonging to those clusters. But optionally, I can also specify something called as a color map, where if I specify it as rainbow, it will be choosing the rainbow colors and assigning it to different clusters. I will give this plot a title as agglomerative clustering. I will give the x label as petal length and I will give the y label as petal width, and then I will plot the data. So, if I see this, the data has been organized into 3 different clusters. So, the agglomerative clustering has been successful on the data to cluster the data into 3 different clusters. Now, I need to check how far the result of clustering matches with that of the class labels that is given in the data set. So, first I will try to extract all the class labels which is present in the data set at column 6, and the column 6 will be having the index of 5. So, I will try to extract all the column labels. So, if I try to print the target values, I will get the target label information. So, all of these are in the form of categorical labels, but always it would be better to deal with numerical values than the categorical labels. So, I will use the label encoder in order to convert these categorical values to numerical values. So, in order to use the label encoder, I will have to import it from the sklearn.preprocessing library. I will import the label encoder and I will create an instance of the label encoder. So, the instance of label encoder has been created. Now I'll try to fit the data for the label encoder so that it can encode the labels and return me the encoded value for these labels. So if I want to convert it, I can do it using the fit underscore transform method in the label encoder. So le dot fit underscore transform of target values. Now where am I supposed to store these target values? Let me consider I am trying to update this column itself, where I will try to change the species from these values to the numerical labels. So I will try to update it in the data set itself. So iris of species, the column name is species. So iris dot species is equal to le dot fit underscore transform of these target values. So what it does, it will be fitting the label encoder with this target values, and it will be returning the encoded values and storing it in the species column within the iris variable. So if I execute this, the operation is successful. So now if I try to print the value of iris dot head, see here previously I used to get iris setosa. If you see clearly here, I used to get it as iris setosa, but now it has been changed into numerical labels. Iris setosa has been given with a value of 0, iris versicolor is given with a value of 1, and iris virginica is given with a value of 2. Now that I have converted the categorical labels to numerical values, I can try to analyze the labels on a graph. So I will try to plot both of the results of clustering as well as the class labels simultaneously and see how far clustering has been successful in identifying the 3 classes. For that I will be using the subplot. So subplot I will be giving 3 different values. So if I give it as 1, 2, 1, what does that mean? I will be plotting one row with 2 columns, and here I will be plotting the first column of data. In the first column, I will be printing the result of clustering. I can directly take it from here and I can display it. Because I have already plotted, I won't waste any time in writing it again. Now in the second column, I am supposed to plot the result of class labels. So I will be using subplot of 1, 2, 2. So this means that first row, in the first row, there are 2 columns and the second column is being plotted now. So I will use the same data and make certain changes in it. So this labels is corresponding to the clustering labels, but now I want the class labels. So class labels I will be giving it from the iris dot ilog. Class labels are present in the column 6 with index 5, and I will be converting it into an ND array and giving it as input. So since I have used the color map as rainbow for the previous one, let me not get confused with the colors. I will be using different color maps in both the places, and here I will be using a different title. Let me say that it is original class labels. And now if I try to plot this data, I will be able to visualize it clearly. So let me make the figure a little bigger so that you will be able to see it clearly. Specify the figure size to be say 15 in the horizontal direction and 6 in the vertical direction. So if I see this, the data has been plotted. So this is indicating the results of agglomerative clustering, and this is indicating the original class labels for the data. So if we see clearly, we can see that the clustering has given us almost the same results as that of the class labels, but only a few data points in this regions have been misclustered. With this, we have learned how to apply agglomerative clustering on the iris data set, and I hope that given any other data set, you will be able to apply this concept for clustering. With this, we have come to an end of all the sessions on clustering, and I hope that you found the sessions useful and informative. Thank you.